All right. Nonlinear inequalities. I don't know what you did in Algebra 2, but I do know that you should know how to graph a linear inequality. And what we're going to do is we're going to look at solving polynomial inequalities, solving rational inequalities, and using inequalities to model real life. Okay, solving polynomial inequalities. What we have is between two consecutive zeros, a polynomial function values must be entirely positive or entirely negative. Does that make sense to you? So if I had a graph and I had zeros here and here, okay, that means what happens between here and here? Well, the graph, I either connect it here to here, or I can connect them from here to here. If part of it was positive and part of it's negative, what happens? We get another zero there. Okay, so between two consecutive zeros, the polynomial or the polynomial function has to be entirely positive or entirely negative. Polynomial functions can change signs only at their zeros. So in solving an inequality, the zeros become what they call critical numbers of the inequality, separating the real number line into intervals in which a polynomial has no sign change. By testing one x value from each of these intervals in the function, the sign of all function values in the interval can be determined. So first thing we need to do, example 1, find the zeros and set up testing intervals using the zeros. So how will I find the zeros of this function? Set it equal to 0 and do what? How do I solve a quadratic and set equal to 0? Factor it. This one's going to factor to x minus 6, x plus 1. So where will its zeros be located? At 6 and at negative 1. What's that? So how many different intervals do we have? We have 1, 2, 3. So down here below, I kind of spelled it out for you. For the intervals from negative infinity, this is interval number 1, call this one 2, call this one 3. So from negative infinity to negative 1, evaluate the polynomial at, give me a number. You can pick any of these. I'm just going to pick the smallest one, negative 2. So the polynomial's value is when I plug them in, I'm going to use the factored form. So negative 2 minus 6 times negative 2 plus 1. What's a negative 2 minus 6? Negative 8 times negative 2 plus 1. Negative 1. So the value is 8. So the interval between negative infinity to negative 1 Is it a solution or is it not a solution? We're looking, we want to see where x squared minus 5x minus 6 is less than 0. So is 8 less than 0? No. So it is not a solution. So for interval number 2, that's between -1 and 6. What value am I going to pick there? I'm going to pick 0. I'm going to go to the original function here. Because when I plug in 0, what happens? These go away, and I can quickly see that its value is 6, -6, sorry. So the interval between -1 and 6, is it a solution or is it not? It is, because I want to find everything that's less than 0. So this one is solution. And then for the interval from 6 to positive infinity, I'm going to go ahead and just pick 7. I'm going to use the factored one because that's 1 times 8. So that answers 8. So the interval from 6 to positive infinity is or is not a solution? Is not. You can verify your results graphically, and you can graph it. I hear a wait. Did we get it taken care of? If I graph it graphically, can you see between where the graph falls? It falls below the x-axis between those two intervals, those two x-intercepts in the middle. Now, we're not going to fill all this in when we do these problems. We're going to use a number line to do all that. And we'll do a lot of this work in our head. Let's just kind of set the stage. Questions? What's that?
The last blank is
-1 to 6. Because that's where my solution is right here. All right. Example 2. Solve this. We want to know where 3x cubed minus 4x squared minus 12x is greater than or equal to -16. What's the first thing we need to find? 0, so what's the first thing we need to do? Well, first we need to add the 16 over. How do we factor something that has 4 terms? Grouping. And hope it works. If not, then we're going to have to go back to figuring out what those zeros are. Well, these two have what in common? An x squared. So that gives me 3x minus 4. Oops. What does 12x and 16 have in common? 4 I'm going to plot a negative 4. And that's 3x minus 4. And now what do the two have in common? The 3x minus 4, which is x squared minus 4. And that has to be greater than or equal to 0. So you have zeros where? Positive and negative 2. Where else? 4/3. So we have a negative 2, positive 2. Where does 4/3 fall?
1/3 after 1.
It's about 1/3 after 1. So here's 1. There's 2. So 4/3 is going to be about right here. Okay, so there's our zeros. I personally don't like to put anything else on there. Now I need to pick the values between them. Well, what's the value over here? To the left of negative 2. Negative 3, so that's going to be our test point. What value between negative 2 and 4/3? Pick the easiest one there is.
0.
0. 0. What's to the right of 2? 3. What falls halfway between? Well, there's no whole number between 4/3 and 2, so you're going to have to pick a fraction. So 4/3. What about 5/3? Because isn't this 6/3? Isn't 2 6/3? So we're going to test 5/3. Now, does the numeric value matter? We're just looking for when is this positive or negative. So do I care if it's a positive 12 or a negative 12? The only thing I care about is the positive value, the sign. So if you look at 3x minus 4 and x squared minus 4, when you plug in a negative 3, when I plug in a negative 3, is this going to be positive or negative? Well, that's going to be a negative 9 minus 4 is negative, so that's going to be a negative. What happens when you plug in a negative 3 here? It's positive. It's 5, so it's positive. So a negative times a positive is negative. So this side is negative. When you plug in 0, go right back up here. What do you get? 16. So this one's positive. Five-thirds. Well, 3 times 5/3 is what? 5. So that's positive. That's what we have right here. And then 5/3 squared is what? 25/9, which is less than 4. So this is going to be a negative. So in between here, this is going to be negative. And then when I plug in 3, well, I'm going to get a positive and a positive. So this is positive. Spill it. So we want to know, where is this positive at? Where is 3x squared minus 4x squared minus 12x plus 6 greater than or equal to 0. Well, that is on this interval and on this interval. So it's on the intervals between -2 and 4/3 and 2 to infinity. Now we have to decide, do we include those endpoints? Well, it's greater than or equal to 0, so do we include the endpoints? Yes, so we include them. So instead of parentheses, we need to use brackets.
Would it be wrong if you put a bracket at the infinity?
Yes. Because we never include, because we don't know when the very end is. Because infinity goes on forever, so we need to mark that it does. So we just, infinity never has brackets. All right, solve each of the by analyzing their graphs. Graphing calculator. So the first one is x squared plus 6x plus 9. So from the graph, I can see that its vertex is at 3, and it goes up. So when is this graph greater than 0? Not always. It's always greater than 0, but at the vertex, it's not equal to. So this value is going to be from negative infinity to -3. Don't include -3, and then -3 to positive infinity. All x's work except for that -3. This is the union sign. This graph, when we graph it, it has vertex at -2. X squared plus 4x plus 4, when is it less than or equal to 0? Well, it's never less than, is it? Because it's all above. But it's equal to 0 where? -2. So x equals -2 is our only answer. For this one, when I do the graph, the vertex is above the x-axis, somewhere here. So when will this graph be greater than 0? Always, so this would be all reals. You want to do interval notation, could write it like that. This one here has vertex at 3. And when will this graph be less than 0? Never. So this is a no solution. Questions on these 4 graphs? I didn't take the time for you guys to put the stuff in the calculator because I think you know how to do that. Questions? All right, those are polynomial. What about rational inequalities? Well, the value of a rational inequality can change signs, again, only at its zeros and its undefined values, which are the x values that make the denominator 0. Use these critical numbers to create the test interval. Be sure to exclude from the solution set any values that yield a 0 denominator. Any interval involving these undefined values must be an open interval at these undefined values. All right, so first thing we need to do for this one, we need to subtract the 1 over. It has to have 0 there. So this is going to be 3x minus 5 over x minus 3 minus 1 has to be less than or equal to 0.
Minus 1 goes in the bottom.
No, it's out. It's the fraction. It's like 1/2 then minus 1. Now, we've got to make this one fraction. We have to get a common denominator. What's the common denominator going to be? Well, there's only one denominator here. It's x minus 3. So the other common denominator has to be x minus 3. So I multiply top and bottom by x minus 3. Less than or equal to 0. Is x minus 3 divided by x minus 3 1? Yeah, it's 1. It's the same. It's some number, the exact same number divided by itself. It's 1. And now, when we add or subtract fractions, denominator doesn't change. And we take 3x minus 5 and we subtract x minus 3. So 3x minus 5 minus x plus 3. I'm doing several steps here. Some of you may be able to go from here right down to the answer, but I'm doing one thing at a time so you can see what I'm doing. So 3x minus x is 2x. Negative 5 plus 3 is negative 2. So there's that polynomial function that we need to work with. Yes, ma'am.
Why does the 3 become positive?
Because I'm subtracting this whole thing. Other questions?
What happens to the 1 chance that you brought over?
This one here,
Yeah.
it's right here.
Oh, okay, gotcha.
And then I combined it. Other questions? All right, so now we need to find where this fraction is 0. We need to find where it's undefined. So where is it going to be 0 at? Zeros are found when the numerator equals 0. So that's going to be at x equals 1. And it's undefined when the denominator equals 0. So our testing points are 1, well, our intervals are 1 and 3. Where's 0 fall on our intervals here? To the left. So we're going to use 0 here. What number am I going to use between 1 and 3? 2. What about over here on the right of 3? 4. So when I plug in 0, what do I get here? So that's positive. When I plug in 2, well, do you get a positive or negative number at the top? Positive on top, negative on bottom, so the whole thing is negative. And then 4, we're going to get a positive on bottom, positive on top, so positive here. So we want to know, when will this fraction be less than or equal to 0? It's when it's what? Negative. So where is it negative? Between 1 and 3, equal to, so which one or both of these intervals do I include? Do we include the 1? Yes. Do I include the 3? No, why not? Because 3 is where our function is undefined.
What if the function was undefined at 4, then would we?
Then 4 would be part of our endpoints. Questions? Example 5, find the domain of 216, or the square root of 216 minus 6x squared. We're used to just doing what with these? What do you know about what has to happen underneath the square root? It can't be negative, so we know that it has to be what? Has to be greater than, can it be equal to 0? Yeah, I can square root 0. So we know that what's underneath there has to be greater than or equal to 0. So now what are we going to do? Well, now it's just like the previous problems. We need to find the zeros. So what's x equal? 216 divided by 6 is 36. Square root both sides, we get plus or minus 1. Do what?
Did you mean 6 or 1? You said plus or minus 1. Did you mean
I missed it. Yes, plus or minus 6. Sorry. So then our intervals are -6 and 6. Zero falls right there between -6 and 6. So 216 is bigger, so this one's positive right here. That's the easiest one. 7 and -7. Well, when I square both of them, we get 49. What's 49 times 6? It's bigger than 216, isn't it? So these are going to be negatives. So our interval is going to be between -6 and 6. Do we include the 6 in the -6? Yes, because it can't be 0. Questions? What? We're finding its domain. So by finding this domain, we know this has to be greater than, we don't have to worry about it. Any other questions on that one? One more fun one. A rectangular parking lot with a perimeter of 440 feet is to have an area of at least 800 feet. Within what bounds must the length of the rectangle be? So we know what? Its perimeter has to be 440. What's a formula to find perimeter of a rectangle? Length plus width plus width. That's Pythagorean theorem. That's the sides of a triangle. So 2 times the length plus 2 times the width has to be 440. All right. So we know that the length plus the width has to be what? If 2 times the length plus 2 times the width equals 440, they're going to equal 220. All right, that's one formula. We also know that the area has to be at least 8,000 feet squared. That should be feet squared. How do you find the area of a rectangle? So we know that the length times the width has to be greater than or equal to 8,000. Within what bounds must the length be? All right, so I need to write this in terms of length only. Well, if the length plus the width equals 220, what's the length going to have to equal? Subtract W. 220 minus W. Oh, we need width. We need to solve for width, sorry. Easy enough. I want to write it in terms of length. So we need to subtract L. So the width will equal 220 minus L. So this is where we need to use to find our answer. So what do I need to do? Distribute. So 220L minus L squared has to be greater than or equal to 8,000. I'm going to take everything over to this side. Subtract the 220L, add the L squared. So 0 has to be greater than or equal to L squared minus 220L plus 8,000. Here's where this nice graphing calculator comes into play. This won't factor, so you'd have to use quadratic formula. But let's get this calculator out. Let's put this in. X squared.
Wait, why did you get the plus 8,000?
Why did I what? I subtracted and added these over to this side.
Oh, I didn't have any.
Well, I didn't want to have a negative in front of the L squared. So L squared minus 220L plus 8,000. In our calculators, we've got to use X. Let's hit graph. It doesn't show up on my calculator because I'm between 10 and negative 10. So I could do a zoom fit, which I think is 0. That didn't work very well either. Yeah, because zoom fit, it only showed us, yeah. What? Did you do zoom fit?
Yeah.
Yeah, that's what I have too. Straight line. Didn't work very well. So let's go to Windows. Let's pick the X values to be between negative 200 and 200. Let's go by 50s. And let's do minimums between negative 10 and 10. Do you care about anything but that x-axis on here? No, we don't, because we just want zeros. So let's hit graph and see if we hit there twice. There it is. I don't care about the vertex. I don't care about how high it is. I just want to find those x-intercepts. So my windows, if you need to see my windows again, negative 200 and 200. That got me out way far on either side. I went by 50s. And then I just put so that my y maximum min is between 10 and negative 10, so that it would show my x-axis right in the middle. You guys find those zeros. Do you have a graphing calculator? Nobody has, very few. Someone come up here and find the zeros while I help. Who wants to find the zeros up here? You could use Desmos. Zoom fit just sometimes don't do zoom fit. Zoom fit gives just a straight.
How do you agree?
There.
Are you sure you're doing Shashi too?
So it's x squared plus 8,000.
Yeah, I think it's reversed. ELI wins. Hey, Mollenbacher, I have the X's.
Thank you.
My shirt guard. I swear that every day. Didn't do that yesterday.
There's not show
Dude,
going.
why are you taking my phone?
It's 220, not 20.
That's your what's that big?
Honestly, no, it's not. I can't fit all of them.
My stickers on your phone. There was like, I remember doing this as far as
All right. So what'd you find for the x's?
I don't know how to do that.
What'd you get for x-intercepts?
45.969.
45.969 and
174.031.
031.
I can do that.
How? Second, calculate zeros, which is 2, and then I'm going the wrong way. Why is
I think it's just skipping over it because it's so steep.
okay? So still should be on there. I don't, mine's doing really funky things.
Mine's doing that too.
So we'll worry about that later. Okay. All right. So we've got to figure out test values. Plug in 0. What do we get here? We get a positive. Well, and you know what? You can look at your graph. We want to know when is this function going to be, when's it going to be negative over here? Well, it's going to be negative between these two, right? So by looking at the graph, we can see our values are negative between these two zeros. So that's what we want. Why do I want negative? Because of the way my inequality sign is. When is 0 bigger than this? So our answer is going to be
What's the other number?
what's what?
The other 0.
0.174, 174.031.
Wait, so you what number? You just plug in a number.
I have the graph here. I don't really need to even do this. I can look at my graph and see which part of the graph is negative.
Oh.
Which part is underneath that x-axis. So our answer, our length, what are the bounds of the length? Somewhere between 45.969 and 174.031.